introducing yourselves and giving a brief TLDR about what your technology is about.
Yeah, hi, my name is Oana. I'm the Chief Success Officer at Partisia Blockchain Foundation. Partisia Blockchain is a layer 1 blockchain that is focused on solving for three key drawbacks in blockchain, which is around privacy, interoperability, and scalability. So we work with multi-party computation. We've been researching multi-party computation for about 35 years, implementing it in commercial examples for about 15 years now. And about 4 years ago, we put that MPC technology and we layered that on top of a L1 blockchain. So that's what we did.
Hi everyone, I'm Alex, I'm CEO of Secret Labs. We're developing Secret Network, which actually is the first production confidential computing blockchain. The technology we're using is called TEE, Trusted Execution Environment. It's a hardware-based solution with Intel processors having a special black box, so-called. It's called Intel SGX, in which arbitrary code can be run without the owner of the machine being able to get to the code or the data. So on our blockchain, the TEEs, those black boxes are used to run the smart contract, so all the inputs and the outputs of the smart contracts are encrypted, so essentially everything the user is doing on chain, be it DeFi, gaming, NFTs, transferring tokens, everything is encrypted and fully opaque to an outside observer.
Hey folks, Itzhaki. I'm the CEO of Fhenix. We're an FHE-based L2 and co-processor on top of Ethereum. A little bit about background. I used to work at Intel for many years. I managed the Intel TEE team. Worked very closely with the likes of Secret and others. We've done tons of TEs. Decided to actually start an L2 based on full homomorphic encryption, FHE, just because I do think that cryptography works best for certain use cases, and we'll talk about that in a minute.
Good afternoon, everyone. My name is Ismael. I'm one of the founders of Lagrange Labs. We build a SQL-based ZK coprocessor. So we let you prove SQL computation or historical storage, transaction, or receipt data to your contract. So think of doing analytics, but something that you can prove verifiably on chain.
Okay, so each of these technologies is being criticized for different reasons. Right? We have the TEs, we are always criticized for being broken too often to be taken seriously. MPC is criticized for its overhead requiring a majority trust assumption. FHE is
no criticism.
FHE is criticized for requiring MPC and not being an independent solution. And there are also challenges with ZK in terms of handling shared private data and composability. So despite this criticism, you chose your respective technology. Why?
Well, first of all, I just want to say how exciting it is to see so many people that want to talk about privacy or confidential computing technology. Even 2 years ago when I went to conferences, I said MPC. People were like, what is MPC? What is MPC? But now people are excited and they're looking to learn more about it, which is extremely exciting for me. The reason why I'll talk a little bit about the pros and cons of MPC. So why it's exciting to me is that it changes how people look at data. And for me, it's really about changing the paradigm of buying and selling your data. Because right now, you guys are buying and selling your data when you give your data to Amazon, or I'm sorry, not Amazon. I mean Amazon. Sorry, Amazon. When you buy and sell it to Microsoft, right, or to Google, you're basically selling your data. And what MPC does, and what the other technologies that are here, what they do is now you're only buying and selling the use of your data. You keep the ownership of the data to yourselves. You own that data. You're not giving it away anymore. And you're only allowing the use of that data. And to me, that's the exciting part. You're really changing the paradigm of how globally in the world we look at how data is used. So, yeah.
So Secret has been on mainnet for I think around 5 years now already, and back then TEs were probably the most or the only practical technology for running general purpose compute on-chain and encrypting the data. And I might say it still is one of the most practical technologies to do that today, if not the most practical technology. Now, the criticisms, the trade-off that you are embracing working with TE is you have to trust the manufacturer, right? The TE itself, it's hardware, it's not open source, you cannot check what's going on inside. So you have to trust Intel, you have to trust AMD or Amazon for that matter, right? They also have their own TE. And yes, in the past there were some more successful attempts to break the TEs. They were later patched and fixed, and I think now the TE landscape is much more mature, and we see more and more projects. You know, a lot of those projects are present here, including the organizers, that are using TEs for various purposes. And also we see that companies like NVIDIA now suddenly start introducing TEs into their chips. So this technology is kind of getting this, you know, there was a hype cycle, then a disillusionment, you know, classical, now it's in steady growth. So that's TE, that's the answer to criticism. And I think for a very long time still going forward, TEs will be the more practical in many ways, both in performance and programming, because on TE, in the end, you just write a regular program, you put it into this black box, and it just becomes confidential, right? So you don't need to do some very sophisticated programming. So that's our take.
I would say we probably should split the discussion into two separate topics. The first one is the need for confidentiality, which I always like to talk about, but given the audience here is probably familiar with the lack of Partisia and why we need to solve it, the next discussion is, okay, so how do we solve it? And yes, there are ways to do it with MPC, external proofs and TEs. My belief is that FHE is actually the end game. And for those of you who don't know, FHE, full homomorphic encryption, it's been out there for, I'd say, several years, but always have been considered as very slow and very complex. There's been significant progress in the last couple of years in both fronts. In terms of complexity, we have, I think, some members here from Zama, which were utilizing their FHE libraries. Significant progression there. Today, we're very easy to use, solidity-based. Developers don't need to understand cryptography at all. They just encrypt or decrypt whatever they want to. In terms of performance, again, also significant progression on the performance side, and the uniqueness of FHE is that unlike MPC, which is communication bound, and that's a hard problem to solve, with FHE, it's computation bound, which means the more hardware you throw in on FHE, the better performance you get. And there are over a dozen companies that are actually building hardware acceleration for fully homomorphic encryption. So the end game for me would be FHE for the computation part. We'll talk about how it aligns with other cryptographies. But I would actually also like to challenge a little bit about the TE part, because yeah, it's true that TE can work, but the gist of it, what you do is you take data, you decrypt it, and you operate over that decrypted data. In the clear, it's just secure by running inside the hardware, which is excellent and it's fast for many applications, but there's some trust assumptions that you need to take, which we believe you don't need to take these assumptions with fully homomorphic encryption. I'll pause here.
Yeah, I think those are great answers by everybody on the panel. So Lagrange doesn't focus on privacy preserving computation. We focus principally on verifiable computation. How do we take something that's too large to do on-chain in your smart contract? How do we lift this off-chain, generate proof of that computation that can then be verified back on-chain? So because of that, we really have to think through what mechanism is best for verifiable computation, because for us privacy is not really a requirement. On-chain data is inherently already not private. So TEs, while obviously practical to some capacity in the simplicity of being able to write computation and then executing them, really have a central trust assumption, to the point earlier, on the party designing that environment. And so that means that you're building effectively an entire financial system on top of cryptoeconomic security and the centralized validator set to lift your computation into income. We don't really think that that is a very compelling selling point to a lot of our customers from a co-processor standpoint. And so in line with that, there are really three mechanisms that we've seen in crypto have any real meaningful adoption for securing the safety of a computation. And that's cryptoeconomic mechanisms, that's optimistic mechanisms, and that's ZK mechanisms. And for what we do, we think that comparing cost of capital on economic mechanisms versus issues that are inherent to finality time monopolistic mechanisms to computational cost on ZK mechanisms, ZK, the computational cost, was low enough that we thought it was the best solution.
I feel a bit hurt about the comments on TEs, but...
Sorry, I don't want to get anything thrown at me here. I know it's a TE event.
No worries. I mean, it's fair and it's very important that we actually address all the shortcomings of the technology that we are using, especially when a lot of money is involved. And I personally believe that in the future, all these technologies will advance further, and we will see a new future, an even brighter future. But another thing that I wanted to discuss is, so people assume that these technologies are competitive and pin them against each other, like we've just seen. But we, at least at Automata, believe that these technologies are complementary, and it looks like more and more that in the future we're going to have a blend of one or of two or three or all of them. It doesn't have to involve these. So I want to know what's your take on that.
Yeah, and I also take that same approach. And as these confidential computing technologies become more well known, I think it's going to be important for all of you builders here to understand the nuances between the technologies, because as you guys kind of heard, there's always different takes and different use cases, and one is a little bit, is advantageous to a particular situation, but it may not be for the other situation. And so from my perspective, I do agree that a lot of our technologies can complement each other. So as an example, multi-party computation is exactly what that name implies. It's multiple parties being able to collectively collaborate together to do a project computation. Well, yeah, that's great when you're able to do multiple different parties together, but it is also very, very network intensive. It is not CPU intensive, but it is very network intensive. So, and then we also talk about TE as a trusted environment. So we have to put a trust in a hardware vendor. But if we layer MPC on top of TE, we can actually improve upon that security model. The same thing with FHE. So I think from my perspective, it's important for you guys to understand the nuances, the differences, the different use cases that your particular application needs, so that you can choose the right technology or a combination of technologies. But I absolutely buy into the collaborative nature of all of our technologies.
Yeah, which I think collaboration between all the decentralized confidential computing DCC technologies is an important message that we'll bring here. And it's not just for us being nice guys and sitting here and not just being at each other's throat, but there is real value in combining technology. We just had a great panel at Decompute of how TE potentially solves issues with MPC like collusion or removal of the keys. Here you go. You combine the two, you get a better product, right? At Secret, we have a project called Reclaim that uses ZK-TLS, and they store the proofs inside the TE. So the metadata of who has which proof is not available, right? So if I generate a proof, say, of my account balance, ZKTLS proof of my account balance in the bank, I don't want other people to even know that I have that proof, right? So if it's stored in a TE-based, or for that matter, any other confidential computing blockchain, but it's TE-based in our case, then it produces a better outcome for the user. Now, with FHE, we just presented a solution actually done by a researcher. His name is Sandogi. So he presented a solution where secret network scalability is greatly improved for certain use cases by using FHE, like an additional FHE layer, where some of the data that's sitting in TE is relatively more expensive to read, is stored in an FHE layer and makes the network much more computation intensive. So in those examples I just showed how, combining TE with each one of the three other pillars creates a better solution. I'm sure there are examples that do not include TE, or you can combine. Well, I know that in FHE projects, MPC is required, right, and sometimes TE is also required exactly for improving the MPC security. So I think the future is in some combinations, and of course, different technologies are good for different things. It's not like we're all competing for exactly the same use case.
So I'm not a developer, but if I was a developer, I would be actually quite happy with the discussion that's happening here, because it gives developers a set of options to pick for the use case that they're trying to build. I want to trade that with FHE, you can do an encrypted mempool, because you can. You will have to use a TE for that. But if you would want to do like a lending platform, if you want to do a voting platform or an auction platform, that's a place that I would actually say FHE is a really good fit if you want to do something around financial data. So it really gives the developer a set of options to pick with. I will say that the end game from our perspective is always and will be a combination of the different technologies, because as we mentioned, each of them has a limitation. Zero knowledge is a proving mechanism, it's not a computation mechanism. MPC has computation limitation, even though there are several projects that are trying to address communication limitation, and there are projects that are trying to address that, and FHE is clearly slower than the others. So there is a set of limitations. Combining these technologies together can actually help solve them both from a technical standpoint, but especially for you as developers, just give you the option to pick the right tool for the use case that you're trying to solve.
Yeah, so in line with me wanting to slice up a little bit, I'm going to take a different view than I think the other three people on this panel. And I'm going to say that for a lot of applications, there's not really a reason to have all of this cryptography played together. I think a lot of things that people want to do on chains can be solved with a single point solution. For example, asserting the verifiability of a computation, I think, is something that naturally in the end state is done with zero knowledge. I think you move away from optimistic and cryptoeconomic and TE-based mechanisms as the underlying proving systems and proving hardware become more efficient. It's very easy to spot directionality. This is more of a statement if we look at a very long time horizon. The mechanism of being able to prove an arbitrarily large execution verified in finite time is way more powerful than the other mechanisms when the overhead becomes low on proving that computation specifically for the purpose of verifiability. For confidential computing, for privacy, I am not as much I'm not an expert anyway in that, so I'm not going to speak to whether or not that's useful. I'm going to give one example, privacy preserving machine learning. This is something that I think is in fact very interesting, because it's a very natural example of where you would in fact want to use multiple technologies. Where the application isn't purely verifiability, it's confidentiality within verifiability. So if I want to outsource the proving of some machine learning model to a remote server, I can't just send my data there. I have to send something that's either encrypted, that's then decrypted within the prover, or I have to do a TE, or I have to do something with FHE. There's a complexity there that has to be solved with multiple technologies. That's more nuanced than simply verifiability of the computation.
Thank you. And unfortunately, we don't have more time. We have to cut it here. I would like to hear more from you guys, but thank you for joining me, and I like how you don't always agree with each other, and I think that's a very important thing for critical mentality is always important. Thank you.
Thank you very much. Thank you.